Thank you for joining us for the EBI Women in STEM seminar series. Our guest speaker today is Corinne Scown, who recently started a company and has dedicated her work into understanding life cycle assessments, sustainability, and circular economies, all while holding positions at EBI, the Joint Bioenergy Institute, the Lawrence Berkeley National Law, and UC Berkeley. Hi, Corinne. Thank you so much for joining us today.
Thanks for having me.
So today we are going to try to understand the basics of the topics I mentioned Corinne specializes in and how that affects our climate. As I mentioned before, I really want to focus on your specialty and ask how your current research focuses on energy and biosciences.
Sure. So we do what's called life cycle assessment and technoeconomic analysis in my group. And the whole point of that is to take technology that might be in the pretty early stages of development. Maybe this is something where you're doing bits and pieces of it in the lab. You maybe have some sense for what the application might be, but we don't yet know how it's going to kind of all fit together in like a commercial scale facility or multiple facilities. What infrastructure do we need to support the scale up of kind of take the data you have and figure out like what would I do to build this at a commercial scale? What kind of facility would I need? What equipment would I require? How much energy is it going to take? What are the kind of material inputs and outputs? And you'll simulate that through software. And you'll end up with kind of cost estimates, so capital cost, operating cost. You'll also get a good idea of the mass and energy balances, sort of what are the inputs, what are the outputs. And then we can take the data we get out of that technoeconomic analysis or TEA and feed it into the models that we build to do life cycle assessment. And life cycle assessment, the goal is to understand the impact on the environment. So what's the greenhouse gas footprint? How does it affect climate change? Are we going to be able to reduce emissions relative to kind of the status quo? What's it going to do in terms of water consumption, air pollutant emissions, burdens on disadvantaged communities? Those are all questions that you can answer with life cycle assessment. So our research is aimed at, figuring out how we can scale technology up, but also understanding the sort of potential impact that it'll have.
Perfect. And I know I mentioned earlier a circular economy, right? And I know that you specialize in, it seems to go hand in hand in terms of a life cycle assessment and what the end goal is to combat climate change. What does a circular economy mean?
It's a great question because people use those words and they mean different things depending on who you're talking to. We have a lot of, what one might call like linear supply chains, where we are extracting resources that are not renewable. So oil, natural gas, we're using those to make products. So in the case of plastics, we will take some fraction of the petrochemicals that come out of those processes. We will make plastic products, packaging, durable goods, et cetera. And then very little of that gets recycled, right? In the US, it's well under 10%. And the rest of that material, for the most part, goes to the landfill. So we use it once and we throw it away. And some of that stuff ends up leaking out into the environment. Folks have seen pictures of, plastics in marine environments. The impacts can be really significant. And a circular economy really means trying to kind of close that loop. So rather than a linear supply chain where we're discarding a lot of material and having to use more natural resources, we want to be able to take the waste at the end of that, the use phase of those products and turn it back into products that are just as valuable. We do, some of that, the more tractable thing to do in a lot of cases is downcycling. Take mattresses as a good example. There are take back programs for mattresses, but it's really hard to take a product like a mattress and turn it back into, valuable products or turn it into another mattress, right? Sometimes you might just be shredding it up and using it as like the cushiony material in like a dog bed or something. So it's a lower value application. It's not quite a waste, but that market is limited. the value is low, and at some point you'll saturate it, and then your material becomes a waste again, right? In contrast, we've made a lot more progress on polyethylene terephthalate bottles, they're PET. So soda bottles, water bottles, we can recycle those, melt down the PET, remanufacture new bottles. And so that's kind of what we look for when we talk about a circular economy, is being able to kind of cycle that material back into applications that are similarly valuable, at least to what they were originally used for.
Does it help us understand what exactly got us to this position of like the emissions being bad? We need to change something, climate is getting worse, and or does it help us understand what we need to do in order, obviously what we need to do, but does it help us understand both of them?
Yeah, LCA can help you identify that low-hanging fruit, like based on where things are today, what are the things you would want to do first to reduce emissions? But you can also use it to evaluate these long-term strategies and sort of run out a scenario where you say, like, what if I deploy this new technology, what's it going to look like in 20 or 30 years?
What is your day-to-day in terms of your work with analytics specifically?
Yeah, well, so for the life cycle assessments, just to walk you through the kind of modeling that we do, we use a method called physical units-based input-output assessment in my group. And the actual code underlying that model is not super complicated. It's some basic matrix math. And the way you should imagine the data being organized is you have this giant input-output table. So you have, and it's supposed to represent, like, maybe not the entire economy, but all the parts of the economy that we care about. Mm-hmm. And you'll have different sectors or activities or products. So you might have like a ton of biomass as an output, or a kilowatt hour of electricity, or a kilogram of fertilizer. And then across the columns, we're representing all of the things that go into making that. So if you want to generate a kilowatt hour of electricity in the US, you're going to need some natural gas, you're going to need some coal, you're going to need some uranium for nuclear, you'll have some solar and wind, you'll have some hydro. And so that's how we track kind of all of the inputs that go into making a unit of something. And when we ultimately run these models using the input output table and what's called impact factors, sort of the impact of producing each one of these things, you get a full supply chain view, not just like the direct impacts at like the power plant, but you get everything that happens in the supply chain. And it spits out a life cycle footprint. So life cycle greenhouse gas footprint, for example.
Perfect. Thank you. That was a really good way of explaining it because I personally understand now. And out of many things you could have done in terms of your career, why did you decide to focus your career in this specific field?
Well, I wanted to feel like I was making a difference. And, I care about mitigating climate change. I have 2 little kids. I want the world to be as wonderful and as pleasant a place to live in for them as it has been for me. Especially living in the Bay Area, like it's beautiful here. I want to be able to preserve that for my kids and their kids and everybody else's kind of subsequent generations. And we're facing a really urgent problem, and it requires big solutions. And I think the research that I do plays a role in that it helps us prioritize which technologies are going to help really get us there.
Lastly, with what you have learned and dedicated your work to, what is the biggest takeaway that you would want college students like me to understand in regards to life cycle assessment, sustainability, and circular economies, and how can we personally better the climate?
Well, first of all, this research is really, really fun. I wish everybody could give it a try. But the main takeaway is that if you care about making a difference, there are so many different ways to do that. And it's really up to you to sample all of your options and do a little introspection and figure out like what excites you, what makes you feel like you're good at it and you want to learn more. The thing you're going to be best at is the thing that you find exciting and motivating. And so by doing, internships at companies, doing, research internships with faculty on your campus, you can get an idea of what you find to be most interesting and motivating. And then I'd say just continue down that path, take another step. Are you still enjoying it? Okay, great. Take another step and see where it leads. It's hard to predict where you'll end up. But I think if you do that, you'll end up doing something you really enjoy and feel good about.
Perfect. Well, thank you so much for such a great conversation. It's truly admirable to see a woman so accomplished in your career and still working to understand how we can help the climate while in this state of crisis. I, alongside EBI, would like to thank you for your time and your wisdom. We look forward to seeing what comes next from you, and we wish you the best of luck in all of your future endeavors. Thank you all for watching. Please make sure to like and subscribe, as well as click the bell to be notified for our next interview. Our socials are linked here as well as on our website. If you're interested in climate change, renewable energy, biosciences, and all that comes with that, and also looking to see what career path you would like to take if you're interested in that, we highly recommend checking our socials and website out.